Hello, everybody. Good morning. This is our Organic Chemistry 2330 final countdown office hours. So the first thing I want to do is go ahead and do some administration. Our final is on Friday, May 8th from 11 a.m. to 1:30 p.m. Okay. The final is 50 questions, multiple choice, administered on sapling. You will have exactly 2.5 hours to complete it unless you have an ODS waiver, where you'll have the time and a half available to you. Other than that, that is our last grade for this class. Our homework is due tomorrow afternoon on May 5th at midnight, actually, so that hopefully we'll have all those grades in and done. Thank you all very much for sticking with me and trying to transition through this part of the semester. I tried to look at the class average, and the class average is about the same as it was before spring break as after spring break. So I think overall, you know, we're adjusting and adapting to this new thing. And so thank you very much for trying, and I hope you've it's been helpful to do the videos and stuff like that. As far as our YouTube video channels going, it's looking pretty good. We have, for this playlist, 39. We'll have 40 as of this afternoon. And then total views on my channel, it looks like over 2,700 views. So I'm thinking a lot of those are bots. But some of them are, you know, you watch it, you take some notes, watch it, take some notes, and hopefully that gives you an opportunity to really, you know, things that don't make sense, you watch it a couple times and it starts to make sense. So I'm really kind of thinking that these kind of videos would be a nice addition to a regular long course, because we have to get through so much material so quickly. So anyway, if you want to go ahead and comment in the chat or on the video channels, that's fine as well. Okay, so again, go ahead and do your questions in the chat here. I'll follow that along as we go. For preparation for the final, okay, it's 50 questions, multiple choice, A, B, C, or D, administered through sapling. You will be able to answer a question, go through and answer all the questions and go back and review, okay? The questions might have you might have to do more than one thing. For example, I might write something on the order of, okay, I'm giving you ethyl propionate and I want you to react it with one equivalent of base. What's going to happen? So you have to figure out that, oh, it's an ester, which means, oh, we're going to do some kind of clazen. So I need to draw out the structure, go ahead and write the base, figure out what my product is, and pick my products from the ones available. So, so that being said, preparing for this, so you recognize functional groups, you recognize nomenclature, is going to be really helpful for you finishing this in a reasonable amount of time. So as I said before, I'd like you to prepare several sheets. One is a nomenclature sheet, and this starts if you look at the slides, the way I do nomenclature, I started the number of rules, and then each time we added a functional group, I added new nomenclature, okay? Now, the best place to start might be actually in the carboxylic acids chapter, because all those carboxylic acid derivatives, and so carboxylic acid is the highest priority. If you have a carboxylic acid, you name it for that. So that being the highest priority, then you have aldehydes, ketones, and then alkenes, alcohols, etc. And so you get the priority set up for your highest functional group priorities are in that carboxylic acids chapter. So almost building it backwards might be a good way to start. And then, of course, you know, you go back to the original rules of longest parent chain, smallest number on the substituents, alphabetization of substituents, and do all that. So that should be your nomenclature helpful sheet, and include chapter numbers and include page numbers. If you had like something E and Z, you want to double check E and Z, include the page numbers on that. RNS, include a page number on that. That makes it really easy for you to go back and review, to double check, make sure you got your answer right. The second sheet, you can actually have two things on that, would be bonding and properties, okay? So the different types of bonding. We have, you know, sp, sp2, sp3 hybridized orbitals. That's very important. know that most sigma bonds, use an sp2 or sp3 hybridized orbital. All your pi bonds use a 2p orbital, stuff like that. So it's important. That would be something you'd have on your bonding. Included in that is structure. Like when we looked at ketones, you know that the carbonyl was sp2 hybridized, meaning it's trigonal planar. Okay, so these are the kind of things you would want to put on that bonding. The other thing to put on that bonding is all the different bonding types. Okay, so there's ion-ion, ion-dipole, dipole-dipole, dipole-induced dipole, and then the van der Waals or London force kind of bonding. Look at all those different kinds of bonding and how those different types of bonding affect boiling point, melting point. Okay. For example, carboxylic acids have the highest because they can hydrogen bond not only to other things, but also they dimerize together, giving you that 8-membered ring where they dimerize together. And that gives it the highest boiling points because of that interaction, other than ions, of course. In addition to that properties, you look at hydrogen bonding, which things hydrogen bond stronger than less. We've talked about thiols and alcohols and amines and how they all hydrogen bond differently and how they all affect the properties differently. So that kind of trending is very important. The last little thing is the more spherical something is, the lower the melting point or boiling point because it has fewer interactions. So that kind of correlations property sheet would be the next thing. And then the last one, it's probably going to be the longest one, it might take up more than 2 or 3 pages, is functional group transformations and the reagents required for that. Okay, I'm going to show you an example here again. And so on this, we have something like, this one says alcohol to ketone or carbonyl. And so then we have to specify what reagents might do this transformation. And then what those things might be. Like PCC will take a primary alcohol to an aldehyde, but a secondary alcohol to a ketone. But if you, let's say you didn't want to stop at the aldehyde, then you can use all these more rigorous reagents. So you would want the transformation, the different reagents that can be used, and what those requirements or what those specifications for those. And then also add page numbers here. If you add page numbers to here, it'll help you go back and, you don't want to write a book about this. You want to have a table of contents for you to correlate a whole semester all in one place, and then say, oh, these are all the different reagents at my disposal. Oh, and guess what? I can look, if the question asks about a reagent, I can look down my reagents and figure out what the transformations were and what the specificity is. So this is all about you building it so that you are correlating all the different chemistries that we've talked about in your head and kind of, and getting it with the book. So you and the book are kind of, on the same page, so to speak, actually, in, an actual case, sorry for the pun. But that way, we've done a lot of different things. And when you start writing this down and look at all these transformations, you're going to be amazed at all the different reactions we have, all the different reagents we have. But we also know that these make alcohols, these make ketones, these make other things. So you'll start to see the order, the periodicity, and the system that we have here. And again, you need to build this so that because you're going to think of it differently than I think of it, than somebody else thinks of it. And as long as you're building it and it's in an order you understand, then that's the most important thing. I think you'll have a really kind of holistic view of organic chemistry just by building this sheet. I mean, you're going to have so much, you'll be amazed at everything we've done this semester just by looking at your sheet you build. Okay, so that being said, let's see. Oh, things to make sure you have on there is some weird ones, like a reaction I was thinking of that would be on your sheet that you might not remember is that if you have a Grignard reagent and you accidentally put it in a solvent that has a more acidic proton than your Grignard anion, you actually end up making an alkane that way. It's not technically a reaction, but if you put your Grignard and an alkyne together, what you're going to end up with is an alkane and your acetylide salt. So that's something to think about, that maybe that might be a side note, in your Grignard reactions, you can't use acidic protons, you can't have protic solvents, etc. You know, things like that. That would be in your notes section. You know, nucleophiles are stronger in aprotic versus non-protic. Halides invert order in protic versus non-protic. Things like this would be something that might show up on your sheet. Okay, so any direct questions about those things I suggest you use to prepare for this exam. Again, it's open notes, open book, but having your prepped sheets, number one, lets you review the entire semester. Number two, you've outlined it in a way you understand it. Number three, it is going to, kind of solidify all the different concepts together. Okay. Go ahead and use the chat or go ahead and unmute, and we can answer any questions here. After a minute, after I answer all the questions about this, what I'm going to do is I'm actually going to stop this. And unless you have really good questions, I'll just post the shorter video on there first so that people can look at what the review for the final looks like. And then the specific questions we'll put on another video. And so we'll stop this in this, I'll start another meeting and we'll all log back in. Okay? So does anybody have any questions about the review pages, when the final is, how the final will be taken? Okay, so what I'm going to do now is I'm going to quit recording. I'm going to log out. That's going to save this video and let me upload it, and then we'll all log back in. All right.
I need to ask about taking the final on Thursday.
Okay. Email me that, and I'll see if we can do that.
Okay.
I think I know how to do that, but email me about that. Okay. All right. I'm going to stop recording.